Hi, welcome to my channel. Today we'll be solving a problem on plane kinematics of rigid bodies, dealing with the slided crank mechanism. So the question asks us to, given this mechanism, which is a slider crank, common in your reciprocating engines, we want to find an expression for the angular acceleration of this rod, connecting rod AB. Now, given a steady angular velocity here of omega naught. So how do we find that? So we could draw a rough sketch here of the points A, and this is the center O, and this is the point B. Now, what lengths are we given? We're given this length here, L, we're given this length R, and this angle is theta. This angle between the crankshaft and the horizontal, theta. And the rate of change of theta, or theta dot, is the angular velocity. So that's given to us already. So let me just write this here. Theta dot is omega naught. Also, we want to find the angular velocity, omega AB. Now, if you have this angle here, let me name this angle. Let me name this angle rho. If I name this angle rho, and now rho is the same thing as the angle between the connecting rod and the horizontal. And the time rate of change in this angle, talking about angular velocity, is the time rate of change of whatever angle it is actually angular velocity. So I will know that rho dot is what I'm looking for, is omega AB. Now we're told to take omega AB and the angular acceleration of AB to be positive, and also rho double dots is also the angular acceleration. So that is alpha AB. So we'll find this expression. So this is a kinematic problem. So we'll be dealing with geometry. And what geometrical fact can we find here? We can find that at any instant in time we have a triangle. And no matter the angles which these links make, this triangle must obey the law of sines. So we could write here that the law of sines. So that's how kinematic problems work. You look for a geometric relation or constraint, whatever we could use to analyze the motion. So in the law of sines, we say what? We have A over sine A equals B over sine B. So in this case, we have R over sine rho. R over sine rho equals L over sine theta. So this relation must always stand. Now, we could cross multiply. If we cross multiply, we have cross multiplication this way. I have R sine theta equals L sine rho. And I want to isolate the function containing rho on its own because that will help me find the derivative. I divide by L, I have sine rho equals what? R sine theta over L. And now I'll take a time derivative. Take time derivatives. So now we take time derivative of this function. This function depends on rho. I'm looking for the time derivative of rho. I have a function with respect to rho. We could use the chain rule that if you want a function d rho over dt, now this is what I'm looking for. But I'm looking for this function sine rho, the change in this. So now if I had here that what I could say d sine rho over dt, this function depends on rho and rho depends on t. So by our chain rule, we can say it is d sine rho d rho times d rho dt. Hope you know this is just basic chain rule. Now this I know to be what? I know this to be cos rho, and I know this to be rho dot. So I've taken the derivative of the left side. Now I have to do the same to the right side. Now what would happen on the right side? R and L are constant. I can bring this out. So this is RLD the t sine theta. Now same with theta. Sine theta depends on theta. Theta depends on time. So could do the same thing, which is what? D sine theta, the theta, multiplying the time derivative of theta, which is theta dot, which is cos theta. Now theta, the theta dot dt is, the theta dt is theta dot, which is still omega naught. So now we have this. Okay, now that means this line tells us that what? This line tells us that cos, when we took the derivatives of both sides, cos rho dot equals equals R over L. Don't forget an R over L I didn't write here. Cos theta omega naught. Now all that's left to do is move this over, and then I write rho dot equals R over L cos theta omega naught divided by, now let me just put the division here, cos rho. Now we have a function rho dot, which is our angular velocity we're looking for, which is omega AB. So this is omega AB. But I want this cos rho dot in terms of the variables I have here, which is L, R, and theta. I do not want it in terms of rho. So here we have, and will you make use of this, that if L sine rho equals R sine theta, and we've said before that sine rho equals R sine theta. So let me put it in this form, R over sine theta. We could use the relation that sine x equals square root of 1 minus. So, I mean, we're looking for cosine. So let's use cosine. The same works for sine and cosine. So cosine x is equal to 1 minus sine square x, square root of that. I mean, this comes from the cosine sine identity that if you square them both, they give you 1. So we could put this now that what cosine rho equals square root of 1 minus sine square rho, and cosine rho equals, now what is sine square root? Sine square root, if I square this, I have the sine square over square root of sine is r squared over l squared sine squared theta. So I take all this and I sub in here. Then I have 1 minus r squared over l squared sine squared theta. Now I could take this and substitute this to get the final answer that omega AB, which we know to be rho naught, this is also, or omega AB, whichever one. Omega AB is R over L omega naught cosine, so you could multiply this, cosine theta divided by what? 1 minus r squared over l squared sine squared theta. That's all that there is to it. So this gives you a relationship for the angular velocity of the connecting rod in with using R, L, and theta. It's all a function of R, L, and theta and omega naught. So that's how you get the angular velocity. So the B part says get the angular acceleration. Now the angular acceleration of AB is the rate of change of this here. which is omega AB dot. So that is differentiating this with respect to t. And since we said it's also equal to rho double dot. So two ways we can get this. One, I differentiate this with respect to t. Now all this, what depends on t, this depends on t, this depends on t. That's a way to go if you differentiate with respect to t. So differentiating with respect to theta, since this only depends on, the only variable here is theta, this is our constant. So this also depends on t, but we see in the question that this is constant, it doesn't change, so its time rate is 0. So we can differentiate this with respect to theta alone, then multiply this by the time derivative, which is omega naught again. We'd have an omega square in that answer. But let's see if that's true. There's another way to do this, is to go here and also use the chain rule again. So we could try both ways, but I will just try this. I would use this relation here. Where is my relation? I have this here, and I will use this. So let's get kicking. Remember here we were told that what the cosine of rho dot equals r over L cos theta omega naught. To find the angular acceleration, we differentiate this with respect to time again, and knowing the chain rule again. So this is a product of two functions. We have to find the derivative, we have to use a product rule. Keep one constant, differentiate the other, plus keep the other constant, differentiate the other one. So I differentiate this and I keep this constant. I have minus sine rho. Now remember, this is with respect to rho. I have to differentiate it with respect to time again. I have a rho dot. So this gives me minus sine rho dot. Remember, there's also a rho dot there. So these two rho dots will multiply to give me a rho dot squared equals, this is what? R over L constant. So this is what? Minus R over L sine theta. Now, you have what? You have theta. You differentiate this with respect to theta. You have a, what do you call it? Theta dot. Now, remember this was theta dot. This omega naught was theta dot. So let me write theta dot here, because that will really help us. Now we have a square here. Plus, what else do we have? We have cosine theta double dot, because we have to keep cosine theta constant and differentiate theta dot double dot. So I hope this thing is in view. So oh Lord, it's not in view. So I hope you can see this. Now, once we have gotten that, let me just narrate it. I think I went out of view for a bit. I have cosine rho dot equals r over L cosine theta dot. Differentiate this with respect to time. You have minus sine rho dot squared. Okay, there's a plus here. You have to add this. This gives you plus. So on this side, you also have to keep cosine constant. Plus cosine rho double dot, and that's what we're looking for. Now, this question says something. Let's remember, it says what? A constant crank speed. A constant crank speed omega naught means that the time derivative of omega naught is 0. So we could cancel this. And then we have cosine rho double dot minus sine rho dot all squared equals minus r over L sine theta dot squared. Now it all has, what we have to do now is a lot of substitution and manipulation. So let's get started. I have this. So let me make sure this is on the other side. So I hope this is in view. So I start by writing this line again, but I move this to the other side because I want cosine rho dots, double dots on this side alone. So I have cosine rho double dots equals, I have sine rho dot squared minus r over L sine theta dot squared. And now I can move this over here. I have rho double dot, which is equal to AB, remember, is equal to sine rho dot squared minus r over L sine theta dot squared divided by cosine rho. Now, all that's left to do is substitute what rho is. I want to remove all rho's from here. That's going to be hectic. So, first of all, sine rho. So, what is sine rho? Remember what sine rho is? Let's check here. We have sine rho being r sine theta divided by L. So this is r sine theta divided by L. Now, what is rho dot squared? Rho dot is all this mess here. Rho dot is all this mess here. So rho dot squared, we're going to square all this. Okay, let's do that. This would be r squared over L squared omega naught squared cos squared divided by what? This whole thing in the square roots. This whole thing is 1 minus r squared over L squared sine squared theta. Now, I shouldn't have written all that in its full form, honestly, because that's not being used. I'll substitute this with a variable. So we have sine theta. Now, theta dot squared is omega naught squared. And now, our life is be made more easier. We can simplify out of this. Now, why can we simplify out of this? From this, we could bring out, you can bring out RL on each side. I have RL, omega naught squared and sine theta common to both. So let me bring that first out. Sine theta, omega naught squared. Now, our lives has been made a bit easier. Not too easy, but I mean. So, once I remove this, I have what's left is this and all this mess. So I have r squared over L squared cosine squared theta, so theta here, divided by square root of 1 minus r squared over L squared sine squared theta. Now, okay, good. This is factorized, so I have to let me wipe this. Minus, take this all out, minus 1. Quite easy how all this went out, divided by square root of 1 minus r squared over L squared sine squared theta. Now, what else do I have to do now? Let me just simplify. It's all done. It's all in terms of theta, r, and L. So the equation can be done here. But let's show that this is equal to this. We have to simplify this further because this is way neat. So we have this here being the same as this, but I want to simplify this further. So I simplify this further by changing the bottom. I make sure this here is the denominator here, and you know how to change a fraction like that. So let's r over L omega naught squared sine theta. Now, what is this line? This line will be what? Now, this is not square rooted. Pardon me, please. This is just like this. Okay, this line will be r squared cos square theta minus, this would be L squared into what? 1 minus r squared over L squared sine squared theta divided by L squared 1 minus r squared over L squared sine squared theta. If I'm to expand this, just this bottom, I would keep this again, so I don't want to write this again. Okay, let me just write it, not being lazy. So r squared over L sine theta times what? Now, this is r squared cos squared theta. This right here is minus L squared times minus. This L squared will cancel this. These negatives cancel to give you plus r squared sine squared theta. Now minus L squared. Right? Now divided by L squared. Now this whole thing should be all the square root of 1 minus r squared over L squared sine squared theta. Now, what do we have here? This should go down with this to give me what? So I have an L squared here, and then this can go down with this. They meet together to give me 1 minus r squared over L squared sine squared theta. Now this is also, this is a square root, so it's raised to power half. This is raised to power 1. They add together. 1 plus a half is 3 over 2. And we know that. So, okay, now we're close to the answer now. So this, you should know this identity. Cos square theta plus sine square theta is 1. So r squared cos square theta plus r squared sine is just r squared. So what do I have? I have this. Let me just simplify the top. I have this to be r squared minus L squared over L squared. Or if I simplify the top further, it will be r squared over L squared minus 1. I hope that's clear. So our final answer is what? R omega naught squared over L sine theta r squared over L squared minus 1. Now, all divided by 1 minus r squared over L squared sine squared theta raised to the power of 3 over 2. Fairly easy. So that's it. And that's how you get it. Thank you.